Good afternoon, ladies and gentlemen. We're going to do the reaction rate law lab today. And my dog wanted to join in and say hello as well. First part we're going to do is part A in your lab. So please find part A in your data table, and you're going to need to record the reaction times for how long these reactions last. Okay, so I've already made up all of the solutions that need to be done for part A. So in our first reaction, I have 2 milliliters of 1 molar hydrochloric acid and 0 milliliters of water. For reaction 2, I have 2 mils of 1 molar hydrochloric acid and 1.5 milliliters of water. And for reaction 3, I have 2 milliliters of 1 molar hydrochloric acid and 2 milliliters of water. I'm going to add to the first cup for reaction 1, 3 milliliters of 0.30 molar sodium thiosulfate. As soon as I add the thiosulfate, I'm going to start timing the reaction, give it a little swirl, and when the X disappears, that's when I'm going to stop my stopwatch. So I give it a little swirl, watch the X. And you can see it's starting to change color and get a little bit cloudy. As soon as that X disappears, I'm going to stop my stopwatch and record time. And time is at 25.84 seconds. So I'm going to record that, 25.84 seconds. All right, now we're going to look at reaction 2 of part A. I'm going to do the same thing. This time I'm adding 1.5 milliliters of the sodium thiosulfate. Give it a little swirl. We got to keep that consistent throughout the experiment. And we're getting close. Okay, the X has disappeared. 37.50 seconds. And now we're going to do the same thing for reaction 3. This time, I'm adding only 1 milliliter of the sodium thiosulfate. Give it a little swirl again. I would say the X is disappearing right about now. This is at 1 minute and 3.19 seconds. We want everything in seconds and not minutes, so I'm going to convert that to seconds. 63.19 seconds. So we've now concluded part A of the reaction. Next, we're going to do part B. Okay, now we're going to look at part B. With part B, we're now changing the amount of hydrochloric acid that we are adding to each of the solutions. So for reaction 4, I'm going to add 3 milliliters of 1 molar hydrochloric acid. And I'm going to do the same process. As soon as I add the acid, I'm going to start timing, give it a little swirl. And when the X disappears, we will stop timing. And stop. We are at 34.06 seconds for reaction 4. Next, we're going to look at reaction 5. This time we're adding 1.5 milliliters of 1 molar hydrochloric acid. Start the stopwatch, give it a little swirl. And the X is disappearing about now. We're at 59.50 seconds for reaction 5. And the last one we're going to look at is reaction 6. This time we're only adding in 1 milliliter of hydrochloric acid. Give it a little swirl. Reaction is starting to get cloudy. X is disappearing right about now. And we are at 34.85 seconds. All right, I'm going to walk you through one of the calculations for the lab. I've tried to color coordinate everything for you, show you what these concentrations are. Normally I'd have you calculate these on your own, but I thought with us not being in the classroom it might be a little confusing. So I've already done those for you. As far as figuring out your average rate, what you're going to do is you're going to take your reaction time and take the inverse of that number. So down here is where you would show the work, sorry, new pen, where you would show the work to get your average rate value. So I'm going to take 1 over 25.84 seconds, and that's basically the inverse of 25.84. That leaves me with 0.03870 for that number. So that's 0.03870, and the unit is a 1 over a second. For the second one there, it's 37.50 seconds. So I'm going to take the inverse of 37.50 seconds. I'm going to try to anyway. And when I do that, I get 0.02667. Again, 4 sig figs here because my seconds had 4 sig figs. That 0 there, remember, is a placeholder. So that value there comes out to be 0.02667, 1 over seconds. My first 2 reactions are what you're going to be using in 2A, that very first box there. So that's why I went through those. I want to show you, kind of walk you through how to calculate these. And it's just like what I showed you with the pre-lab as well. So for reaction 1, my reaction time is 0.03870. And for reaction 2, my reaction time was 0.02667, 1 over seconds. And I'm taking the concentration of sodium thiosulfate from reaction 1, dividing it by the concentration of reaction 2, and bringing it to some x power. 0.18 divided by 0.090 is 2.0 to the x power. 0.03870 divided by 0.02667 comes out to be 1.451. So 4 sig figs, that number is going to have 4 sig figs there. To calculate the value of x, I'm going to take the log of the number on the right, 1.451, divided by the log of the number on the left, 2.0. Calculating that. And remember your parentheses when you're doing this. I get 0.5370. Now, sig figs with logarithms. Your answer is going to have as many decimal places as the fewest number of sig figs. I have 4 sig figs, 2 sig figs. Fewest number is 2 sig figs, which means I'm going to have 2 decimal places. So 0.537 would round to 0.54. So that is the order for the first problem that I did there. You're going to proceed with the same process and do this for the next 2 boxes and figure out the average order for sodium thiosulfate. And then you're going to do for reaction 4, 5, and 6, when you are changing or manipulating hydrochloric acid's concentration, you're going to figure out what those average orders are, be able to write a rate law expression, and then also calculate your specific rate constant.